Today's topic is bias and variance, underfitting and overfitting. So we'll see what is bias. The definition of bias refers to the error which has been introduced by approximating a real-world problem, which may be either complex with the simpler model. As we take any simple model, the complexity will be more, which means that the bias which has been introduced by that model will be high. In other words, the bias is a measure of how it is far away from the current value. On average, a model's predictions are from the correct value. So next we are going to see about what is high bias. High bias as a model is overly simplistic. It does not pay much attention to the training data and is likely to cause a underfit, meaning that it poorly performs on the training data and also on the test data. So the validation what we are going to do with on the test data and the training data will be overly validated, or it is going to go for training or the uh, predictions what we're going to make with the training data, the train what the data sets what we got it, we are when we go for under the training process, it may lose some of the data, or it may skip some of the data. So when that problem rises in the training data, the same thing when I'm going to apply it for the test data, there also there's a problem will be carried out, and totally the system says that it is suffering with underfit. That means the bias is very high. This occurs typically with the linear models where the line of fit does not capture the complexity or the pattern in the data. So this is about the bias. Now we'll see what is variance. The variance measures how much model predictions vary from the given data point. When the different versions of the models are trained, example, training on different subsets of the data, it reflects the sensitivity of the model to small fluctuations in the training data. So what they say is that here complexity, so it does its role on, I mean, it goes for the training the given data sets. When it starts training the data sets, so it may vary from a slide, I mean, from the, I mean, whatever the predictions we are going to make it, from that current value, it shifts slightly from that bias. Simply, currently, it starts shifting from the reference point. So what happens? It causes a small fluctuations in the training data set. So what is high variance? High variance model captures noises along with the underlying data patterns, causes a overfitting. So it not only undergoes for training the data sets, along with that it also captures some of the noises along with that. So this is often a complex, happens with very complex models like a deep neural networks or high degree polynomial regression, which pay too much attention to fitting the every detailed values of the training data, including the noise. As a result, what happens? That model perform well on the training data, but it poorly on the unseen test data. It works very highly on the trained data set. Training. When it undergoes for the training of the data set, it behaves properly. It covers all the things, I mean parameters, but at the same time, but it gives a very less test quality on the when I go with the testing of data. So this is called this the whatever the problem I'm facing on this causes is called as overfitting. So this is the graph for overfitting, underfitting, and good balance. High variance. So high variance means the data suffers and what fluctuations, or it also undergoes some differences, or it undergoes it faces some problems under the test data, but it works well and good in the training data set. In that case, the variance will be high. The graph will be like this. Whereas in the high bias, we told that it doesn't even work under training data set, and the same one, I mean, if it is not properly trained in data set, if I'm going to use the same data set for the testing purpose, at the same time that this problem will be carried out and it causes an high biases. So this we told that mainly it occurs in the case of linear regression model. You can see how the underfitting graph is. Good balances, you should get a U curve. So you should have a low bias and low variance. So everything should be low. If it is low, then you can get a proper balancing values or the predictions what we're going to make for this is, I mean, whatever maybe the algorithm will be good. So what are the trade-off we faces in the case of bias and variance? So the bias, the difference between the bias and variance is crucial to building an effective machine learning models. If a model is too simple, so that if already we told that if the model is very simple, in that case the bias will be very high. Unless it does not capture the underlying pattern in the data, it will have a low predictive performance due to the underfitting. Predictive performance will be very low. This is a final suggestion we make under what a very simple system. So conversely, if we go for a very too complex system, that means the complex system which produces a high variance, it will capture the noise along with in the training data set and perform very poorly on the test data, and you can see that it causes an overfitting. So this is under very complex data set. If it is too simple data set, we'll get a high bias. If we have a more complex set, we'll get a high variance. How to make a balancing between this what a too high value of bias and variance? So if I want to have a proper algorithm which matches all this problems or the trade-offs what we face between the bias and variance, we have to think about choosing the right model complexity which is suitable for the size of the data and the variability of the data. Depending upon the size and the variability, we have to choose a correct model to work on that data set. It's the first choice. Next thing is you have to use an techniques such as cross validation to estimate the model performance on the unsigned. So for unsigned data, we have to go for cross validation. So third process is employing regularization. Employing regularization will make the system more effective and you get a proper what predictions we can make it. Next, we'll see what is the usual visual representation we have for this bias and variance. Relationship between the model complexity, bias, variance, and overall error is often is predicted in the form of curve. We call this bias variance trade-off curve. So this is the curve we get it. This is how the model complexity, what type of error we get it, how much is the total error we predicted, and for that what is the variance value and bias value we will see. When the model complexity increases, normally we say that bias will be decreasing and the variance will increases. So the total error is the lowest at a point of optimal complexity where the increase in variance is balanced by decrease in bias. So understanding and managing the bias variance trade-off, we can able to develop a proper machine learning models that perform well on both on the training and data set, so that we can get a very effective predictions and we can say that the algorithm what we adopt for the given data set is right. So we can able to define what type of algorithm, how it works, and what are the problems we face it. According to that, we have to choose a right model to define our data set. This is the what about the variance trade-off between the variance and bias. So the trade-off what we get it finally on this bias and variance. So every time in the machine learning, we know that there is a low bias, accurate. I mean, we say that there is accurate predictions and low variance, consistent predictions across the different data sets. However, it's very difficult to achieve. So the balancing between the bias and variance becomes, it is not just easy to balance it. There are some problems are there. We have to find it out how to make the a good balance we get it. If you make a model more complex to reduce the bias, you might end up with the high variance. So if I start reducing the bias value, variance will increases because your model starts seeing the pattern that do not really exist, which causes a overfitting. If I go for a simplify your model to reduce the variance, that means I'm making more consistent. You may increase. So when I start reducing the variance, the bias will increase. So this will cause us an underfitting. Finding the balance is nothing but you have to go for, you want to make a accurate and also consistent model. In the machine learning, you have to adjust your model so that the complex enough to capture the important patterns, but not so complex that it is starts capturing random noise. So all these things you have to balance it and you have to make the model to work perfectly on the given data sets so that this trade-off is minimized. So what are the techniques we can apply to help it? So in this case, training more number of data set, or you have to do a cross validation or regularization. Already I've told. So training data sets means more data sets make the model to work perfectly. But with more number of patterns or unique pattern you can get it. Whereas in the case of cross validation, if I do it, this is likely practicing on the different dartboards. So to make that you can hit the bullseye constantly, no matter which board you are using. Regularization is nothing but it's likely telling yourself not to put too much force onto your throws. It may prevent from your overfitting or throwing too widely by adding a finality over a complex model. So for the example we are saying it. So you also have to work on it, but we should not make the system to work too much on the data. If I go for it, too much of throwing, I mean, too much of data have been trained or tested for making your system to perfect. Sometimes you may face an overfitting. So this you have to avoid it. This for that only we go for regularizing your